I'm going to divide that number by 8. So whatever the decimal number I'm having, for that I'm going to divide that number by 8. After addition, the resultant is equal to the decimal value of the octal number. And if I consider this example, I have integral part as well as fractional part. Hello to all, a warm welcome to my new session on number system. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, at the beginning, I am going to recall the topics which I have covered in my last session of this unit, that is number system conversion. Along with that, I have covered decimal to binary. So these are the two topics I have covered in my last session of this unit. But in my today's session, I'm going to deal with how to convert binary to decimal, at the same time how to convert decimal number to octal as well as octal to decimal. So here decimal to octal and vice versa. So these are the things I'm going to deal in my today's session. So dear student, at the beginning I'm going to have conversion binary numbers to decimal number. I'm going to have binary number and I want to convert that to decimal number. For that, what I will do, I'm going to start at the rightmost bit. So I'm going to consider the rightmost bit and take that bit and multiply by 2. I'm going to multiply that bit by 2. So I'm going to consider the position, bit position. So if the bit present at the position 0, then 2 to the power 0. If the bit is present at the position 1, 2 to the power 1, at the position 2, 2 to the power 2, and it's going to continue, and nth position, it is 2 to the power n. So when n is the current bit position, so remember here this n is used to specify the current bit position. Usually the bit position starts from 0 and it is going to increase each time, and this is represented as power of 2. So 2 to the power 0, 2 to the power 1, 2 to the power 2, up to 2 to the power n. Then add all the products. Later what I'm going to do, I'm going to add all the products and I'm going to write the decimal value that is equivalent to binary. So what I want to do, I want to find the bit position. Based on that, I want to find the power of that number or power of that bit. Later, what I want to do, I want to add all the result in order to get my product. Now, see here, I'm going to have the example. See, I have the bit. So here 1, 2, 3, 4, 5, 6, 7. So I have 7 bit and power starts from 0 and it is 6. Total 7 bit. So here what I will do, for each bit I'm going to write the position. So I'm going to write the power of that bit. So 1 is present at the 0th position. So 2 to the power 0. If I consider this one, it present at the location 1. So 2 to the power 1. This one present at the location 2. So 2 to the power 2. And here 2 to the power 3. Here 2 to the power 4. It is 2 to the power 5. And here 2 to the power 6. Now, what I want to do, I want to find the power first. So, 2 to the power 0, by the mathematical property, it is 1. So, 1 into 1, it is 1. Now, 2 to the power 1, it is 2. 2 into 1, here it is 2 to the power 4. So, 1 into 4, 2 to the power 3, it is 8. So, 0 into 8, 2 to the power 4, it is 16. That is 2 into 2 into 2 into 2, it is 16. So 1 into 16, 2 to the power 5, it is 32 into 0, 2 to the power 6, it is 64. And what I'm going to do, I'm going to add all the product. So 64 plus 16 plus 4 plus 2 plus 1, so 87. So this is the representation of 87. And dear student, I'll tell you one simple method here. I'll write the binary digit as it is 10101111. So dear student, please remember one thing, that here I will have 1, 2, 4, 8, 16, 32, 64, 128, 256. So it's going to continue. So dear student, first I want to consider 1 and 2. And each time I want to write the multiple of 2. So 2 into 2, it is 4. 4 into 2, it is 8. 8 into 2, it is 16. And 16 into 2, 32. 32 into 2, 64. So each time I want to multiply the position by 2. And same thing I have to write here. So it is 0th position, and for first position it's 2, second position 4, third position it is 8, fourth position 16, fifth position 32, sixth position 64. Now I want to consider 64, 16, 4, 2. So here 64 plus 16, then 4 plus 2, it is 6, 6 plus 1, 7. 10, 10 plus 7, it is 17, 1 carry. 6 plus 1, it is 7, 7 plus 1, it is 8. So 87. Here also I'm going to get 87. So dear student, you can follow either this method or this method. Which one you feel easy and comfortable, you can follow that method. Now I'm going to have decimal number to octal number. So I'm going to have the decimal number and I want to convert that to octal. So what I'm going to do here, I'm going to divide that number by 8. So whatever the decimal number I'm having, for that I'm going to divide that number by 8. Now I'm going to take the remainder and record it on the side. I'm going to repeat step 1 and step 2 until the decimal number cannot be divided further. And the first remainder will be the LSB and the last remainder is the MSB. And the equivalent octal number is then written from left to right. So I'm going to write the octal number from left to right, and this method same as which one? That is decimal to binary. So I'm going to divide that number by 2. Instead of that, I'm going to divide the decimal number by 8. Instead of that, I'm going to divide the number by 8. Now, let's consider the example here. See, I'm going to have the example 3034 and I'm going to divide that number by 8. So 8 3s are 24, 8 3s are 24, 30 minus 24, it is 6. So along with that, I'm going to have 3. Now 8 7s are 56. What I want to do, I'm going to subtract 13 minus 6. 13 minus 6, it is 7. And I'm going to have 4. 8 9s are 72. So remainder is 2. And I'm going to place 2. Once again, I have 3, 7, 9. Once again, divide that by 8. Now, 8 fours are 32. So how much? 7 minus 2, it is 5, 9. Now 8 sevens are 56. So what is the remainder? It is 3. Now I have 47. So divide this 47 by 8. 8 fives are 40 and 7 is remainder. So I'm going to get 5, 7, 3, 2. I'm going to get 5, 7, 3, 2. Now, if I consider conversion octal number to decimal. So here I'm going to convert the octal number to decimal. So what is the step? Start from at the rightmost and I want to consider the bit and I want to multiply that bit by 8 to the power n, and the bit position starts from 0. 0th bit, first bit, second bit, third bit, like that, nth bit. And what's the power? That is 2 to the power 0, 2 to the power 1, 2 to the power 3 up to 2 to the power n. And add all the product. So after that, what I want to do? I want to add all the product, and after addition, the resultant is equal to the decimal value of the octal number. Now, with the help of some example, let me to explain conversion octal number to decimal number. So, dear student, I am going to have the octal number and I want to convert this to decimal. So, what I am going to do? I am going to multiply that number by 8, and this is my 0th position, and this is my first position, this is my second position, and this is my third position. So here 2 to the power 0, 1, 2 and 3. Over. Now 8 to the power 0, by the mathematical property it is 1. So 2 into 1, here 3 into 8, it is 64. Then 8 into 8 into 8, it is 512 into 5. It is 7 into 64. So I'm going to get the result 3034. So this is the decimal representation of given octal number. Now I'm going to have the conversion, that is decimal to hexadecimal. So I'm going to have the decimal number and I want to convert that to hexadecimal number. For that, what I'm going to do? I'm going to divide that number by 8 because I have decimal number and I want to convert that to hexadecimal. So I'm going to divide that number by 16. And I'm going to take the remainder and record it on the side, and I'm going to repeat the step 1, step 2 until the decimal number cannot be divided further. So I'm going to repeat this step until the decimal number cannot be divided further. And the first remainder will be the LSB. That means whatever the first remainder I'm going to get, that is my LSB, and the last remainder is my MSB, that is most significant bit. Now I'm going to have the number 16243 and I want to divide that number by 16. So 16, 1015, I'm having 16, 240 and 2 is my remainder. Once again, I'm going to divide this number by 16. So 63, I'm having 1008. Now I'm having 63. So dear student, 16 3s are 48 minus 63. So 5, 1 and it is 15. Now it is my hexadecimal number. For that reason, to represent 15, I'm going to use the letter F. So I'm going to get the result 3F72. So this is the hexadecimal equivalent of given decimal number. Now I'm going to have conversion, that is hexadecimal number to decimal number. To convert hexadecimal to decimal number, what I want to do? I want to consider the rightmost bit and I want to multiply that bit with the value 16 to the power n, where n is the current position and it's going to begin with the value or position 0 and increase each time, and that represents a power of 16. Then add all the product. Now I'm going to have the example here, and if I consider this example, I have integral part as well as fractional part, and for my integral part my power starts from positive power, that is 0, 1 and 2, and for my fractional part power starts from -1. So it is nothing but the inverse. So 13 divided by 16, and 16 to the power, it is 1, 16 to the power 1, it is 16, 16 to the power 16, 16 to the power 2, it is 256, and I'm going to multiply and I'm going to get the product, and at the end I'm going to add all the products together in order to get my final result. Now I'm going to have octal number to binary. That means I have octal number and I want to convert that to binary. Now take the each bit from octal. So I want to consider each bit from octal. So octal means what? It is 3. That means to represent octal number, I required only 3 bits. Convert each digit to 3 bit. That means how many bits I have, in that I'm going to make a group, and each group must have only 3 bits. For example, think that I have 5 bit. So what I want to make a pair, I want to make a group, and each group must have 3 bit. So it is 0. To make it 3 bit, I'm going to add the 0. So once again it is 3 bit, and I'm going to write the binary. So dear student, let me to consider the example here. Think that I have 5 bit. Now what I want to do? I want to make a group, and each group must have only 3 bits. To make it this bit into 3, I'm going to add 0 at the end. Now it is 3 bit. Here also it is 3 bit. Now let me to consider the example here. So dear student, this is the octal digit, and I'm going to have the binary equivalent. For 0, I'm going to write 30. For 1, 001. For 2, 010. For 3, 011. For 4, 100. 5, 101. 6, 110. And 7, 111. Now let me to consider the example here. This is my octal number, and I want to convert that octal to binary. So what I'm going to do? I'm going to extract individual digit, and I'm going to write the binary equivalent. And while writing, I'm going to start from top to bottom. So this is my final output. For 4, what is the binary equivalent? That is 100. For 5, 101, and for 6, 110, and I'm going to start writing from top to bottom. Now I'm going to have binary number to hexadecimal. So here take the binary number and group of 4. So hexadecimal means what? 2 to the power 4, it is 16. And if I consider 2 to the power 3, it is octal. So to represent that, I can have 3 bits. To represent 16, that means to represent octal number, I can have 4 bit. And what I'm going to do, I'm going to group the 4 bit together. For example, think that I have 11101. So what I will do, I'm going to make a group, and that includes only 4 bit. And here to make it 4 bit, I'm going to add the 0. So here once again it is 4 bit. Now let me to consider the example here. So I have the given number. For example, 1, 2, 3, 4, 5, 6, 7. Total 7 bit, and I want to make 2 group. Each group must have 4 bit, and to make it 4, I'm going to add the 0, and I'm going to write the decimal, that is hexadecimal equivalent of this binary. This is the hexadecimal equivalent of the given binary number. So dear student, let me to consider another example. Think that I have 11011110. Okay, now according to the rule, what I want to do, I want to make a group. I want to make a group, and each group can have 4 bits. 4 bits. 1, 2, 3, 4. 4 bits. And to make it 4, I'll add 0. So it is my. Okay. Now, dear student, I want to write the hexadecimal representation. That is 1, 2, 4, 8. So 8 plus 4, it is 12. 12 plus 2, it is 14. So it is 14. And here 8, 4, 2, 1. It is 13, and here it is 1. Now A is nothing but 10, B is nothing but 11, C is nothing but 12, D is nothing but 13, E is nothing but 14. So here it is D, and here it is E. And what is the answer? 1DE. So it is better to write the weightage. So it is very easy to calculate the hexadecimal number, and if I know the weightage of each bit, and I want to consider only the bit that have 1. So 1 into 8, it is 8. 1 into 4, it is 4. 0 into 2, it is 0. And 1 into 1, it is 1. So 8 plus 4 plus 1, it is 13. And for this one, 1 into 8, 8. 1 into 4, 4. 1 into 2, it is 2. 0 into 1, it is 0. So it is 14. Like that, you can able to calculate. I started with decimal to octal, octal to decimal, and hexadecimal to octal, and hexadecimal to decimal. And in my next session, once again, I'm going to deal with number system, that is nothing but what is BCD, what is Gray, what is ASCII, what is Unicode, all those things I'm going to deal in my next session. So dear students, let's meet in the next session with more information about number system. Until that, keep watching and keep learning. Thank you.